On November 21, 2024, the world witnessed a new chapter in the history of modern warfare. Russian President Vladimir Putin announced the deployment of a brand new experimental missile system called Oreshnik. This wasn't just a test on a remote range, it marked the first time in history that an intermediate-range ballistic missile was used in actual combat operations. Launched from the Kapustin Yar test site in the Astrakhan region, the missile covered 500 miles in less than 5 minutes, roughly the same length as this video. It struck a major military plant in Ukraine, leaving the global community stunned by its speed and sheer destructive potential. Technically speaking, the Oreshnik is a monster of military engineering. The missile weighs approximately 1.5 tons and is equipped with a powerful two-stage propulsion system. During its initial ascent, it can accelerate to a staggering Mach 15, and as it dives toward its target, it maintains a terminal speed of Mach 10. To put that in perspective, Mach 10 is a speed of 2 miles per second. During the recent strike on Ukraine, footage revealed 7 warheads hitting the target, though it is believed the system can carry 8. While the version used in Ukraine was a non-nuclear modification, each warhead is theoretically capable of carrying a nuclear charge of up to 300 kilotons. The range of the Oreshnik is deeply concerning for global stability. Classified as an intermediate-range ballistic missile, its reach extends up to 300 miles, meaning every corner of Europe is within its strike zone. If launched from the Kapustin Yar range, the countdown is terrifyingly short. Berlin would be reached in 11 minutes, Rome in 13, Brussels in 14, Paris in 15, and London in just 16 minutes. This extreme velocity leaves enemy missile defense systems with only seconds to react. Because its maneuverability makes its trajectory unpredictable, the chances of interception are estimated at less than 1%. In fact, experts suggest it would take over 100 interceptor missiles to reliably stop just one Oreshnik. Currently, according to intelligence reports, Russia is estimated to possess only about 20 copies of this experimental missile. However, this is just the beginning. By the end of 2024, Russia plans to launch the full-scale mass production of the Oreshnik system. This signals a significant shift in military strategy, where unstoppable hypersonic weapons become a primary pillar of both nuclear deterrence and conventional strike capabilities. The existence of this weapon forces NATO and Western nations to reevaluate the effectiveness of their air defense systems, which are currently deemed inadequate against a threat of this velocity. Let's look at what would happen if a nuclear modification of the Oreshnik missile struck London. The consequences would be catastrophic. Beyond destroying the historic center of London, the entire surrounding metropolitan area would suffer. The death toll would be colossal, with an estimated 500,000 people killed instantly, and over 8 million more suffering from severe injuries. In addition to central London, the blast would obliterate towns such as Croydon in the south, Enfield in the north, Ilford in the east, and Hounslow in the west. The physical destruction of buildings would exceed 216 square miles, and the entire environment would be saturated with radiation, poisoning the Thames and surrounding water bodies for generations. However, there is a significant point of contention. Western experts are skeptical of Russia's claims and believe the Oreshnik may not actually possess an advanced maneuvering unit. If the Oreshnik is simply a conventional ballistic missile with multiple independent reentry vehicles, MIRV, but lacks active maneuvering during its descent, then intercepting it could be significantly easier. In that case, as it descends, it would follow a predictable trajectory that can be calculated and eliminated by modern defense systems. The line between an unstoppable superweapon and a standard ballistic missile lies in this maneuvering technology. We can only hope that we never have to find out which theory is correct in the real world.